Today I will be going over the homework for targets 8 and 9. Please make sure that you do have your notes out as we go over this because we will be using all of those exponent rules that we talked about in class. For the first one up here, I'm multiplying. I have 4m to the fourth times 3m squared. So I'll go ahead and multiply my numbers together. So 4 times 3 is 12. And then I'll multiply my like variables, so m to the fourth and m squared. Remember, when we multiply our variables with the same base, we add those exponents, so I get m to the 6. On number 2, we just have several different variables. Remember, we want to always look at the ones that are like. So I have m to the negative third and m to the negative 1. So I'm going to start by multiplying those, and I get m to the negative fourth. I have p squared, and I have p to the fourth. So adding those exponents, I get p to the sixth. And then I have q to the fourth and q to the negative third. Again, adding those together, I have q. The one thing we have to remember now is you cannot have negative exponents in your answer. So the negative exponents, we always move to the opposite side of the fraction they're on. So I'm going to move that to the bottom. So I have m to the fourth in the denominator, and my p to the sixth and q stay up in my numerator. On number 3, we have a power to a power. So since there is only multiplication inside of that parentheses, I can distribute my power to everything inside. When we distribute the power, we always multiply the exponents. I know that 3 has an exponent of 1 on it, so that becomes 3 to the third. Multiply 4 times 3, and I get v to the 12th. So on 4, I'm going to continue by distributing that exponent. If you wanted to, you can move those all to the denominator first. The order does not matter. So I'm going to distribute negative 2. So I have m to the negative 6th, p to the negative 6th, q to the negative 8th. All of those have negative exponents, so I need to move all of those to my denominator. So I have m to the positive 6. Remember, once you move them, they have a positive exponent now, so p to the positive 6 and q to the 8th. We can't leave our numerator empty, so we're going to put a 1 up there. In number 5, I have division. Remember, our rule for division is we have to subtract the exponents. In the numerator, I know I have an exponent of 1, so I'm going to do 1 minus 2, so I get n to the negative first. I can't have that negative exponent, so I move it to the denominator. So I have 1 over n. You could also put 1 over n to the first. On 6, I have division. I got a little more going down here, so I'm going to look at one thing at a time. So I'm going to start with my numbers. I have 2 divided by 4. I know that simplifies to 1/2. I have x cubed over x squared. Subtracting those exponents, I end up with x to the first. Remember, when you subtract, it always ends up in your numerator unless it's negative and you have to move it to the denominator. I have y to the negative fourth. It doesn't have any other y's. Since it's negative, I'm going to switch the side of the fraction, so I'm going to move that to the numerator so that it has a positive exponent. Last but not least, I have z to the negative 3 over 4. So I need to do negative 3 minus 4, which gives me negative 7. Remember, we can't have that negative exponent, so when I rewrite this, I'm going to keep my x and y to the fourth up top. Those both have positive exponents. The 2 stays in the bottom, and the z to the negative 7th moves to the bottom, but that 7 becomes positive since we moved it. On number 7, the first thing I need to do is I need to worry about this exponent on the outside. I have a power to a power, so I need to distribute that to everything inside. So I'm going to distribute that to every exponent we have in there, remembering that 2 has an exponent of 1. So that gives me 2 to the negative 4th. Multiplying my exponents, I get a to the negative 12th. B to the negative 16th. I still have this 2b to the 4th up front. We could combine everything now, or we can move all of our negative exponents to the bottom. On the last ones I combined right away, so on this one I'm going to show you moving it to the bottom. So I know everything I have here in blue has to move to the denominator. So I'm going to have 2b to the 4th over, remember when we move it down, everything becomes positive. So 2 to the 4th, a to the 12th, and b to the 16th. Now I can go ahead and simplify. When I simplify my 2's, remember this 2 in the numerator has an exponent of 1. So I'm going to subtract my exponents, so I get 1 minus 4. 1 minus 4 is negative 3. So I'm going to move that to the denominator right away and make it to a positive 3. I have b to the 4th over b to the 16th. 4 minus 16 gives me a negative 12. So rather than putting b to the negative 12 up in the numerator, I'm going to write it right now in the denominator as b to the positive 12th. Then I have a to the 12th in the denominator. It doesn't have any like terms, so I'll keep a to the 12th in that denominator. I have no numerator, so we have to put 1 in there as a placeholder. Okay, so for number 8, again, we can move the next negative exponent first. You can multiply everything first. That is up to what you prefer to do. I'm going to go ahead and move that negative exponent up. So I have vu to the 4th staying in my numerator, and then I'm going to move that v cubed up from the bottom here because it has that negative exponent. In my denominator, I can multiply my 4 times 3, so I get 12, and then I have vu squared. So now I can go ahead and simplify. In my numerator, I have v times v cubed, so I get v to the 4th. I have u to the 4th, and I have a u squared in my denominator. Subtracting those exponents, I'm left with u squared. Excuse me. In my denominator, I still have the 12, and I still have that v. So I have one more step of simplifying. When you're finally simplified, you should only have each variable once. So I see that I have a v to the 4th, and I have a v to the 1st power. So I'm going to subtract those exponents. I end up with v cubed u squared all over 12. Okay, let's go down and look at number 9. So number 9, we have a lot of stuff going on here. We need to distribute that exponent to everything in parentheses. I'm also going to move all those negative exponents down into my denominator. So I'm going to have 1 up top. Then I have m to the 1st n cubed. I'm moving that numerator down below so I can have positive exponents. Distributing my exponent in the denominator, remember that means we need to multiply those exponents. So I'm going to have m to the 12th and n to the 16th. For my final answer, I have 1 in my numerator. When we multiply, we add the exponents. So I have m to the 13th, and I have n to the 19th. Okay, so number 10. You could go ahead and multiply your m's in the numerator if you wanted. You can move the negative exponents to the other side. Let's multiply our numerator here because I haven't done that for a little bit. So m squared, m to the negative 3rd, I get m to the negative 1st. I still have that n to the negative 2 power. In my denominator, I'm going to distribute that negative 2 exponent. So I have m to the negative 2, n to the negative 4th. Now I'm going to flip everything because everything has a negative exponent. So I have m squared n to the 4th moving to the top. Remember, when you flip the side of the fraction, those exponents will become the opposite of what they were. And then in the denominator, I have m to the 1st n squared. Now I can go ahead and subtract those exponents. So 2 minus 1 gives me m to the 1st. 4 minus 2 gives me n squared. So my final answer is m to the 1st n squared. Again, remember, you don't need to be doing these the same way that I do them. There's lots of ways to go about these problems. We just have to make sure that we get to the same answer and we use the properties appropriately. For our last two, I'm going to move those negative exponents. So I'm going to take x to the negative third. I'm going to put that in the denominator as x cubed. I'm going to take the x to the negative 2, move it into the numerator as x squared. I'm going to keep that y squared up in my numerator. And then we have a power to a power, so I'm going to multiply those exponents so I get y to the 8th. So final answer, x squared over x cubed, we do 2 minus 3, which is a negative 1. So I'm going to move it to the denominator and make it positive. Y squared times y to the 8th gives me y to the 10th. Last one. So on this one, again, start whatever you see you can do. You can multiply the top first. You can move your negative exponents first. You can distribute your exponent in the denominator first. I'm going to start this one by multiplying the like terms up on top first. So I have 2. I have x to the negative 4th and x to the negative 2. So negative 4 plus a negative 2 gives me negative 6. So I have x to the negative 6th. I have y to the first and y to the third. 1 plus 3 gives me y to the 4th. In the denominator, I'm going to distribute the negative 3 to everything inside the parentheses. Remember, we distribute it to their exponents. So I have 2 to the negative 3, x to the negative 12, y to the negative 9. I'm going to move everything so that I have all positive exponents to work with. So up top, I'm going to keep my 2y to the 4th. I'm going to move the x to the negative 6 to the denominator. In the denominator, I'm going to move everything up. So I have 2 cubed, x to the 12th, y to the 9th. Now I can combine all of my like terms. 2 to the 1st times 2 cubed gives me 2, adding our exponents to the 4th. Y to the 4th times y to the 9th gives me y to the 13th, adding those exponents. X to the 12th over x to the 6th, remember we subtract when we divide. 12 minus 6 is 6. So that's my final answer. Usually we're going to see that in our alphabetical order. So 2x to the 6th, y to the 13th. On the back side then, we have target number 9, where we are simplifying our radicals. So remember, we want to break these down. We want to try to look for those perfect squares in there. The bigger the perfect square, the easier it's going to be. I'm going to try to continuously look for those big perfect squares here so we don't have to do as much work. I know 200 breaks down into 100 and 2. I know 100 is a perfect square because the square root of 100 is 10. I can't simplify the square root of 2. I can't break that down. So my answer is 10 root 2. Sometimes it can help to write your perfect squares out so you have those to look as you go on. So remember, our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. You can keep going if you want. We can go to 121. We can go to 144. But those are all the numbers that I can take the square root of. So if we can break down our values into those, that's going to be the easiest thing that we can do. So when I look and see 180, I want to think, what is the biggest number I can divide 180 by? If you don't get the biggest number, that's not necessarily bad. You're just going to have to do a little more work. So 180 is divisible by 36. So I can split it up into 36 and 5. The square root of 36 is 6. 5 I can't split up any further. Remember, when you take a square root, you're always going to multiply it by anything on the outside if there is something. So here I'm going to get 18. I can't take the square root of 5, so it's stuck underneath. On 15, I have two things to look at. I'm going to try to take the square root of 98, and I'm also going to try to take the square root of k cubed. If it helps you, break this up into two different problems and look at those two different problems independently. So 98 is the square root of 49 times the square root of 2, because 49 times 2 gives me 98. Square root of 49 is 7. So right now I have 7 square roots of 2. When I look at k cubed, there's several things I can do. We're always looking for groupings of 2. So you can split up k cubed into k times k times k and find your groupings of 2. I think it's easier if we know we're doing a square root. I always ask myself, how many times does 2 go into 3? I know 2 goes into 3 one time, so that tells me I can bring 1k out. When it goes in there, I have 1 left over since I had 3 k's, so that 1 left over gets stuck underneath. Now, I need to combine these two for my final answer, so outside I'll have 7k, and underneath I will have 2k. Again, there are several ways to do these. Some are easier ways for people. Use whatever you understand the most to complete these problems. Okay, next one, I have the square root of 54 and the square root of r to the 4th. Square root of 54, I know 54 breaks up into 9 and 6, and I could break up 6 into 3 and 2. I didn't break up 9 further because I know the square root of 9 is 3. Over here, I'm left with 3 and 2. 3 and 2, neither of those are perfect squares. I don't have a pair, so I can't pull anything out. So I'm just going to multiply those back together and still have the square root of 6. R to the 4th, when I look at r to the 4th, remember we have a square root. I'm going to ask myself, how many times does 2 go into 4? It goes in there twice, so I can bring in r squared on the outside, and I wouldn't have any left over. So we're going to have no r's left underneath our square root. So taking everything from the outside, I have negative 4 times 3, which is negative 12, times r squared gives me negative 12r squared. My square root of 6 is still stuck underneath that square root. That's our final answer. Okay, square root of 28ab cubed. So starting with 28. Need to think of two numbers that go in there. I know that 4 goes in there, and 4 is a perfect square, and it's 4 times 7. The square root of 4 is 2. I cannot simplify the square root of 7, so right now I have 2 root 7. When I go to take the square root of a is to the first power. 2 can't go into 1, so I can't take any groupings of a out. So a is going to be stuck underneath my square root with that 7. When I look at b, I have b cubed. 2 goes into 3 one time, so I can bring 1b out with 1 left over, so I have 1b left over. 18, we have 54x cubed y cubed. We just broke up 54 right above this. So remember, it broke up into 9 and 6. We say the square root of 9 is 3. 6 I can't simplify. It broke up into 3 and 2, but neither of those are perfect squares. So I'm going to keep 6 underneath the square root. Then I have to worry about my x and my y. So right now I have 3 on the outside. I have 6 underneath. 2 goes into 3 one time, so I can bring 1x out. I'd have 1x left over, so I'll have 1x inside. 2 goes into 3 again for the y one time, so we have 1 that can we bring out and 1 left over. Number 9, I'm starting with the square root of 100, but I know square root of 100 is a perfect square. The square root of 100 is 10. So we're not going to have any numbers left underneath that square root. We're going to have to remember to multiply this 10 by this negative 8. So I'm going to have negative 80 on the outside of my square root. The square root of u cubed, 2 goes into 3 one time, so I can bring 1u out. I have 1u left over, so 1u will stay in. 2 goes into 2 one time, so I can bring 1v out. We don't have any left over. So our final answer is negative 80 UV square root of U. 20 also has a perfect square underneath it. The square root of 144 is 12. We took the square root, so make sure that comes out of the square root. Multiplying it by my negative 2 on the outside, I get negative 24. When we go to take our square root of m or n, both of them are to the first power, and 2 can't go into 1, so we can't simplify either of those. We'll have m and n stuck underneath the square root. So 21, I have 8 times the square root of 216. 216 is getting a little bit bigger, so we might not know easily what goes into there. The best way to break this down would be to do 36 and 6, but I want to do one in case you found a smaller number such as 4. Okay. So if you have 4, it's 4 times 54. Again, if you found 36 goes into there, please do that because it's going to make it easier on yourself. I know the square root of 4 is 2, so I can bring a 2 out. I can't take the square root of 54, but I can break the square root of 54 down into 9 times 6. And then I know the square root of 9 is 3, so we can pull it out. We can't simplify the square root of 6. It's not a perfect square. We could break it into 3 and 2, but neither of those are perfect squares, so 6 has to stay underneath. When you have two numbers that you are pulling out, you always multiply them by each other, and then don't forget we have to multiply by the 8 on the outside. So 2 times 3 is 6, 6 times 8 is 48. So I have 48 on the outside. This 6 is stuck underneath that square root, so I still have the square root of 6 there. When I go to simplify my variables, I have x to the first power. Well, 2 can't go into 1, so my x is stuck underneath the square root. 2 does go into 3. It goes into it 1 time, so I can bring 1y out, and I'll have 1y left over. 2 goes into 3 also for the z 1 time, so I have 1z can come out, and 1z is left over. Last but not least, number 22, starting with 28. So I can split up 28 into 4 and 7. Picking 4 and 7 because 4 is a perfect square. The square root of 4 is 2. I'm going to multiply 2 times negative 4 on the outside, so I get negative 8. I can't take the square root of 7. I can't split up 7 anymore, so 7 is going to be stuck underneath my square root. Square root of m squared, 2 goes into 2 1 time, so I can bring m on the outside. I have no leftovers, so we don't have any m underneath my square root. 2 goes into 3 1 time, so I have 1p on the outside, but I have 1p left over, so it will stay on the inside. 2 goes into 2 with my q 1 time, so I can bring 1q out. There are no leftovers, so that is my final answer. Please come in if you have any questions on this. Again, there are several ways you can split those up. There's no one right way. You just need to make sure when you simplify it, we get to the same answer.